with on your own. What do you want to call this 15 feet?
H.
H. We'll call it H. Now it's not changing, so it's not big. We put a variable on it, but that. What about this 10 feet? What do we call that? What?
D.
D. We hate using D because it leads to things like D, D, DT, but whatever.
So B.
Well, we're using D now. We're in. We're going to use it. What do you want to call the shadow length? Which is obviously important.
SL.
SL?
Or S.
S. Okay, so you just chose my least two favorite letters right in a row. Shadow, S, DD. We've got it all going on now. What do you want to call this guy's height?
M.
M, man's height. All right, that's a variable I don't particularly complain about. Now, so we know H is equal to 15. We know D is equal to 10. We know S is equal to I don't know what. Right?
Yeah.
We know M is equal to, was it 6 feet tall? What is it, 6 feet? Okay. Now, your R that you were trying to do is this guy walking this way. What is he changing with respect to time?
The shadow.
He's changing the shadow. Yeah. By him walking away from the pole, he's increasing the S.
Yes.
So when I walk away from a pole,
yeah,
I'm not increasing my distance from the pole. I'm increasing my shadow length. That's what I'm doing.
Well, you're doing both.
I'm doing both, perhaps. But what is increasing at 5 feet per second for sure?
The distance.
The distance from the pole, correct? So wouldn't this indeed be d dt?
Yeah.
I mean, you chose D. I don't choose D often. And this is 5 feet, we said?
Yeah.
5 feet. All right. Working hard. Okay, so the question at hand is two questions. One, how fast is the point of the shadow moving? And how much bigger is the shadow getting as this happens, correct?
Yeah.
Now, with the variables you define, it's probably easy to figure out how fast the shadow is growing. Is that okay with you?
Yeah.
So what are we looking for?
The rate.
But we're going to write that with D's and T's and things like that. So do that, please.
What are you asking?
Okay, so the question I threw out to you is that we're finding the rate at which the shadow is growing. So we're going to use things like D, 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 D something.
Yeah.
And you, as I said, so what are we looking for? And you said S. I know we know D, 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 T. What are we looking for?
S.
Okay, you could have solved that in geometry. The question is, what is the rate at which the shadow is growing? Is that just S?
DSDT.
DSDT. That's what we're looking for. Yeah. At this point, that should be a little clearer. Okay. Right? I want to know the rate at which the shadow is changing with respect to time. That's DSDT. Does that make some sense?
Mm-hmm.
Okay. All right, so now that I've got that at my disposal, now I've got this shape here, and I got a related equation that relates S, D, and H, and possibly M. Do you have any formula to do that? This is the reason why I'm doing this problem, because you probably don't. Although you should. You did about 1,000 of these problems in your life already. You just don't remember them. Nobody does.
So it's not something like that.
Yeah, you haven't done it recently, probably. Although it appears on the SAT every year and on the ACT every year, because I know you've done it. What? Anybody besides Lily know what we're doing? Anybody got a way to relate this and this,
It's that
Pythagorean.
equation.
and this, and this, and this, and this to this, and this to this. Anybody got anything like that?
I don't know.
So you spent several months in geometry heck doing what we called similar triangles, right? Where you said, hey, this is to this as this is to, remember that? Remember that? You did about a billion of those.
20 years.
Now, 3 years ago, billion, 20 years, whichever. So the bottom line is, the reason why I bring this up with great venom and vigor is you have to remember this one because there's a good chance it'll be on your test. They expect you to remember similar triangles because you got it pounded into you. And you will. You don't, and that's fair. Is that okay with everybody? But now you do, right? It's this is to this as this is to this. So we need to write that equation. You ready to write that equation? Here it comes. It's this, which is the h, is to the whole length here, which would be d plus s according to the variables he chose, is equal to m is to s, right? So the big triangles are proportional to the little triangles if they're similar triangles, which they are. Are they similar triangles? What is it? Yeah, similar. Good?
Yeah.
Okay. Now, H is H changing?
No.
No. The height of the lamppost is not changing. Wouldn't that make the problem much more fun if it was?
No.
Is the D changing as he walks away from the pole?
Yes.
Yes. Is the length of the shadow changing as he walks away from the pole? Yes. Is the height of the man changing as he walks away from the pole? Yeah, maybe a little bit, but not for purpose of our purposes. So 6. And we already said the shadow is not changing. The shadow is changing, so we need it as an S. I'm going to simplify this. You want to simplify this? This becomes 15S. Oh, lovely. 15S. I love S as a variable. Everybody should do. Is equal to 6D plus 6S. I'm going to simplify further. I get 9 S's equals 6 D's. Now, how am I going to get ds dt from this equation? If you use the word multiply, your life will be on the edge. So what are you going to do? You're going to take the derivative of both sides. Good call. See, that's on recording, so you can say that for later. ds dt equals 6. Wasn't a death threat. I was saying your life was on edge. I'm not sure who's why. What kind of threat is that? That's not a threat. It's truth. It's not a threat. Okay, 6. So what's dt?
dt is
5. So I get ds dt. The length of the shadow is changing at 30/9 or 10/3. What's my units?
So 10/3 will be
Feet per second. Okay, so that's my ds dt. Now, that was one of the 2 questions they asked me. The second question they asked me was this. They said, how fast is the shadow's tip moving away from the pole?
That's number A.
That was actually A. We did B. Are you with me? Because the bell's going to ring in about 2 minutes, and I don't have time to be not with me. Okay, so I need a variable that describes this distance here. What variable do you want to use?
Do
By all means, never use X. Okay, A. Fuja. Hiya. Okay, so now I'm going to use the exact same equation. I'm going to go H is to A as M is to S, right?
Yeah.
Now H is not changing, so that's 15 over A, which is changing. That's what I'm looking for, right? is equal to the height of the man, which is still 6, over S, which is changing. So that gives me 15 S's is equal to 6 A's. I'm going too fast. S. You chose S, man. You got to live with the consequences. Don't throw your cell phones on the ground. That's an electronics violation. Let's move forward. The look on her face. I know. Hey. Hey. Okay, so 15 ds dt is equal to 6 dA dt. Now, notice something interesting. I don't know ds dt, except I just solved for it, didn't I?
Yeah.
So that's going to be 10/3. I get 15 times 10/3 equals 6 dA dt. And that becomes 50 over 6 dA dt, which is 25/3 is dA dt. Now, I'm going to close this door because we need to finish one more sentence. Okay, so one more sentence. You ready for one more sentence? Okay, this is 10/3. This is the shadow that's how fast the shadow is increasing.
Yes.
I'm also walking at 5 feet per second, which means the end of the tip should be 10/3 plus how fast I'm walking away from the pole, shouldn't it?
Yeah.
The pole would be 15/3 because I'm going to add fractions in a moment. 15/3 plus 10/3 is 15/3 plus 10/3 is 25/3, which is what I got when I did solve for A directly wherever the mess is. What the? Okay, here it is. Feet per second. Does that make sense?
Yes.
Okay, should work every time. Good. Okay, quiz next time. Come with your questions. Try the other problems on that worksheet. Come in ready with questions, or I'm taking a quiz like right away.